Most of the stars glow because of the nuclear fusion taking place inside them. But the pre-main sequence stars or the protostars glow because of the gravitational contraction. When the fuel supply in a massive star runs out, the balance between gravitation and radiation is disrupted and gravity takes over, and this results in the formation of a compact object which can be a black hole, a white dwarf or a neutron star. Einstein left us a clue to solve our mystery. His general theory of relativity suggested that any mass energy would curve space-time. We explain this with a simple experiment of freely falling body. As we see in the experiment, the body undergoes acceleration although there is no force acting on it. This is explained by GR, which suggests that time-space get warped and thus a body moving in a straight line seems to have acceleration. Since light photon too has momentum and energy, it means that trajectories of light too should get curved around massive objects or even around a point. An attempt to resolve the space-time structure around a point mass indicated that the gravity around it would be so strong that even light will not be able to escape. Thus the name black hole. The outer boundary of the sphere of influence of the black hole is known as the event horizon and its radius is known as the Schwarzschild radius. The Schwarzschild black hole has no identifying features and this is known as the no-hair theorem. The curved black hole can be identified with the charge, mass and spin only. Let's look at this from two perspectives. For someone observing ME25 from far away, ME25 would stop at the event horizon. As it falls in, the light and signals from it will have to fight the immense gravitation of the black hole and in this process it will lose energy. So for observers far away, ME25 would be redshifted and its fall will take forever. However, ME25 would see the universe speeding up and as soon as it hits the event horizon, all of time would pass and everything would be blue shifted. Also, near the black hole, the gravitational pull felt at the approaching end of the spaceship would be 1,000 times more than that at the far end. This would lead to spaghettification. Entropy is the amount of randomness possessed by a body. Since a black hole is a point mass, its entropy is equal to 0. Say if our ME25 fell into the black hole, its entropy should increase. But this is not true because the black hole is a point mass and so its entropy has to be 0. So the entropy possessed by our spaceship must vanish and this is not allowed by the second law of thermodynamics and this itself is a contradiction. True black holes have gravitational mass m equal to 0, which means that the negative self-gravitational energy cancels out all positive energies like bare mass and internal energies. So the black hole is a point object with mass m equal to 0. Now let us try to imagine a balloon in the sky. A collapsing star gains heat and radiation pressure, somewhat like a balloon. If we try to heat the air within a balloon, it will try to inflate. Similarly, a black hole before formation, the outward radiation pressure should counteract the inward gravitational pull. And so what we get is a quasi-static black hole, which has the same mass as that of a true black hole and is radiating energy at an infinitesimally slow rate. And so it will take infinite time to become a true black hole. A new claim by Dr. Abhas Mitra stated that GR does not really support the formation of black holes or any horizons at that. The claim was based on the proof that if any horizons would be formed, the stellar mass would behave as photons, which is not allowed. So the concept of eternally collapsing objects were introduced, which should possess a strong magnetic field, and thus the name magnetospheric eternally collapsing objects or MECO. Einstein's field equation does admit the existence of a single point mass that is very compact and dense. Now in GR, for the masses of every object comes from a minimum integration constant. For a single point object, this minimum integration constant must be 0. So for it to be 0, the positive mass energy has to be counteracted by the negative gravitational pull. And so the minimum integration constant can be 0. And thus the quasi-static black hole can exist. And so if there is no black hole, There is no parallel.